In this video, I want to look at solving a linear system that contains three equations with three variables. And while there are a few ways to attack these types of problems, in this example, I want to look specifically at solving the system using elimination as our first step. All right, so I have three equations and three unknowns, so I need to choose two of the equations and use elimination on one of the variables. Well, it looks like the second and third equation, y would be really nice to eliminate because here I have negative 3y and here I have positive 3y. So simply adding the second and third equations together will eliminate the y variable. So I'll do that with the x's, negative 6x, my y's cancel, plus 8z equals 4. And what I notice here is that between negative 6, 8, and 4, they have a greatest common factor of 2. So what I could do is go ahead and divide a 2 out of every single term just to go ahead and make these numbers a little smaller to work with. And that makes them a little nicer. Okay, so I'm going to go ahead and box that. He's an important equation. I'm going to come back to him here in a second. So back to the system here. So initially we used the second and third equations and eliminated y. Well, I need to eliminate y again, but I can't use the second and third equations again because that's just going to give me this. I either need to use the first and second or the first and third. Well, it looks like between the first and second, my signs are already opposites. So it looks like I'll just need to multiply the top one by 3 and the bottom one by 4 to eliminate the y's. So let's go ahead and I'll notate it this way. I'm going to multiply the top one by 3, and that will give us a positive 12y. And I'll multiply the bottom one by 4, and that will give me a negative 12y. And of course those y's will cancel. So let's go ahead and run that 3 through the first one and the 4 through the second one. So 9x is what you get when you take 3 times 3, and then plus 12y minus 6z, and that equals 0. For the second equation, negative 8x minus 12y plus 20z equals, looks like 76. So the y's cancel by design, so I'm left now with a second equation with just x and z, and that's what we want. So x plus, looks like 14z equals 76. Well, there's no greatest common factor here, so I can't divide them all to make the number smaller, so we're okay. And the x is just 1 anyway, so this won't be too bad. Let's go ahead and stack these two equations. So we have negative 3x plus 4z equals 2, and then we have x plus 14z equals 76. So solving this system with two equations and two unknowns, it looks like I can do, well, either substitution or elimination again. If we just go ahead and do multiply the second equation by 3, I can go ahead and eliminate my x's. So let's multiply that through 3x plus 42z equals, looks like 228. I'll rewrite the second equation. He's left unchanged. The x's cancel, again by design, so now I'm left with just z's. So 46z equals 230. So if I divide both sides by 46, looks like z will be a nice even 5. Okay, well if that's the case, let's go ahead and start our back substitution process. Let's plug the z equals 5 into the second equation here. So we have x equals, or not x equals, x plus, there we go, 14 times z, and z is 5, and that equals 76. So x plus 70 equals 76. So it looks like my value of x will just be 6. So now that I have z and I have x, let's continue our back substitution process and use one of our initial equations now to plug in z and x. So let's go ahead and use the first one. That looks pretty nice. We have 3x plus 4y minus 2z, and that equals 0. So that's pretty nice to work with. Small numbers, and it equals 0. So I'm going to go ahead and rewrite that down here at the bottom where we have a little bit more room. Okay. So 3x, well, x was 6 plus 4y, that's what we're looking for, minus 2z, and z was 5, and all that equals 0 from the first equation. So 18 plus 4y minus 10 equals 0. It looks like 4y plus 8 equals 0. So 4y equals negative 8. Do a quick division, and y equals negative 2. So now we have all three values for x, y, and z that we need. So let's go ahead and write our solution as an ordered triplet. And of course we'll do so in alphabetical order, so it'll be x, y, z. So our x value is 6, our y value is negative 2, our z value is 5, and here is our ordered triplet.